Converting from standard form to vertex form is a little trickier. There's actually two methods that you can use. The second method I'm going to go over is actually the more common once you get to the intermediate algebra stage. But I'm going to show this first method because it relies on something that we looked at last week, which is that you can always find a vertex using the formula for x of negative b over 2a, and then finding y just by plugging it back into the equation. Now, the reason this can help you write it in vertex form is that in vertex form, basically you just need a and the vertex. And if you know what the vertex is, and you can find a from the equation, you can just recreate it. So if I can figure out what the vertex is, so remember I need the a and the x minus h squared plus k. So if I can figure out what this vertex is, then I can just plug that in, those numbers in, and then a comes right from the equation. The number in front of x squared is invisible 1, so a is 1. So let's find that vertex and then rewrite these constants in. So the vertex formula is negative b over 2a. b in this example was 10, so negative 10 over 2 times 1. So that's negative 10 divided by 2, or negative 5. Calculating the y value by using the equation that we had to begin with, negative 5 squared for x squared plus 10x, in this case 10 times negative 5, plus 28. If you carry through that calculation, you'll get 25 plus a negative 50, which is negative 25, plus 28 gives a positive 3. So using this information that the vertex is at negative 5, 3, we can plug that into this format and actually create the equation. So f of x is actually equal to 1, which we typically wouldn't have to write. 1 is multiplied by anything, it's just that thing. And then x minus a negative 5 would actually be a plus 5 squared. And then plus the k is 3 here. So we get our equation, I'm going to emphasize it because my writing got a little bit pushed together. The equation for f of x in vertex form would be 1 times the quantity x plus 5 squared plus 3. A quick check, if you wanted to check that, is just multiply it back out. If you multiply it out like we did when we were converting from vertex form to standard form, you will see that it should come back to be x squared plus 10x plus 28. I'll leave that for you to check. Let's look at another example using the same technique. This is the function g this time. Now, with the function g, we actually can see the a is significant here. It's not just a 1, it is a negative 2 because that's the value in front of the x squared term. So I'm going to start with negative 2, and then I'm going to have x minus h squared plus k. So I need to find that vertex using the formula that I had. So x is equal to negative b over 2a. So that would be negative b is 12 over 2 times negative 2. That's a negative 12 over negative 4, so that's positive 3. If I plug a positive 3 into that equation, negative 2 times positive 3 squared plus 12 times 3 minus 16, and calculate. This one I'll just take a little bit more time to calculate. Remember that you square the 3 before you multiply by the negative 2. So negative 2 times 9, 12 times 3 is 36, minus 16. Finish the multiplication here. Negative 18 plus 36 minus 16 would be 2. If you need a moment, pause and double check that yourself. Once we have the x and the y, we have our vertex, and we can plug that back in up here for h and k. So g of x is equal to negative 2 times the quantity x minus 3 squared plus 2. So we basically just fill in the h and the k once we have the vertex. So here we have our function g rewritten in vertex form. So standard to vertex form, we do one method is to find the vertex and just put the appropriate values into the form.